sklearnmetricsdcgscore. Description: the DCG-score function from scikit-learn calculates the discounted cumulative gain DCG for a set of predicted rankings. DCG is a ranking metric commonly used in information retrieval and recommendation systems, measuring the relevance of items in a ranked list, with higher relevance items being given more weight and items appearing later in the list being penalized. Inputs: why true. This is the ground truth or true relevance scores for each item in the list. The format should be a 1D array where the order of scores corresponds to the order of items in the predicted ranking. Y score: these are the predicted scores for each item in the list. This should also be a 1D array, with the order of scores corresponding to the order of items in the predicted ranking. Outputs: DCG, the calculated discounted cumulative gain DCG value. Steps: the function first calculates the discounted relevance score for each item in the ranked list by taking the relevance score of the item and dividing it by the logarithm base 2 of its position in the list. It then sums these discounted relevance scores for all items in the list, resulting in the DCG value. Metrics: DCG: the higher the DCG, the better the ranking performance. It indicates that the highly relevant items are placed higher in the list. Visualization plots: line plot. A line plot can be used to visualize the trend of DCG scores across different iterations or parameters. Bar plot: a bar plot can represent the DCG scores for individual items in a ranked list. Fine-tune parameters. This parameter allows you to specify the number of top-ranked items to consider for the DCG calculation. By default, K is set to none, which calculates the DCG for all items in the list. Log2: this parameter is the base of the logarithm used to calculate the discounted relevance scores. By default, it's set to log2. You can change it to other bases as needed. Uncertainty methods. Bootstrapping: you can use bootstrapping to estimate the uncertainty in the DCG score. This involves repeatedly sampling with replacement from the original data and calculating the DCG for each sample. Challenges and fixes. Challenge 1: handling sparse data. Sample use case that resulted in challenge 1 when dealing with a dataset where many items have a low relevance score. The DCG calculation might be dominated by a few highly relevant items, making it difficult to assess the overall ranking performance. Fixes to challenge 1: consider using a metric like normalized discounted cumulative gain (NDCG), which normalizes DCG scores to account for varying maximum possible DCG values. Challenge 2: choosing the right K. Sample use case that resulted in challenge 2 when the dataset contains many irrelevant items. Choosing a large K value might inflate the DCG score, as it will include many irrelevant items in the calculation. Fixes to challenge 2: carefully select the K value based on the specific application and K characteristics of the dataset. Experiment with different K values to find the one that best reflects the ranking performance.